This is lesson 4.5. We're going to talk about dilations and scale factor. So a dilation is a reduction or enlargement of a figure with respect to a fixed point called the center of dilation. A lot of times our center of dilation will be the origin. A dilation is an example of a similarity transformation in that it does not preserve congruency. So we notice that the old shape and the new shape are different sizes, so the shapes themselves are no longer congruent to each other. What we will produce are similar figures. They're the same shape but different sizes. All of the corresponding angles are congruent. So the original A is congruent to the new A prime, but the sides are proportional. So we're going to multiply the sides to make them bigger or smaller, and whatever we multiply one side by, we would multiply all sides by. All of the image lines, so the new lines, will be parallel to the old lines unless it contains the point or center of dilation, then it would be on the same line. So for scale factor, it's going to indicate how much the figure will enlarge or reduce. We're going to use the letter K for the scale factor. When K is greater than 1, that's an enlargement. If you're multiplying it by something bigger than 1, you're going to make it bigger, so that's an enlargement. But if you multiply by something between 0 and 1, that's a reduction. If it's a negative number, that means it was either an enlargement or reduction, but also a reflection. I'm going to try to not give us any with negatives. If I accidentally do, I'm sorry. But our goal is to focus right now just on the dilations themselves, not including our reflections. The other thing, scale factor is always going to be the new value over the old value. So when we want to find K on a picture, we're going to take the new number and put it over the old number and see what that reduces to. So for example 1, we want to find the scale factor of the dilation and tell whether it's a reduction or an enlargement. So this point here, P, was the original shape, and this point here, P prime, was the image, right? That's the new one because it has the prime on it. So the new value from the center all the way to the new shape was 12. And the old value from the center to the old shape was 8. So I would want to reduce 12 over 8, right? Divide by 4, 3 over 2. So my scale factor is 3 over 2. Because this number is bigger than 1, I would call that an enlargement. Also, looking at the two shapes, the new one is bigger, so that was an enlargement, and it makes sense that my scale factor was bigger than 1. There's a check-in here for you to try. Pause now if you'd like. The answer is posted on Google Classroom. The coordinate rule. So if I'm going to do a dilation of a figure on the coordinate plane, and we're dilating it with the center at the origin, or 0, 0, then all we have to do is multiply each of the values, the x and the y, by the scale factor, which was k. So it will become k times x and k times y. So for example 2a, we have triangle RST. We want to graph its image after a dilation with a scale factor k equals 2. So each of these numbers here, I'm going to multiply by 2. So negative 5 times 2 is negative 10. 1 times 2 is 2. Negative 3 times 2 is negative 6. 4 times 2 is 8. 2 times 2 is 4. Negative 1 times 2 is negative 2. So now if we graph this, we're at negative 10, 2 for R prime. Remember, we do have to label. S prime was at negative 6, 8. And T prime was at 4, negative 2. And if I connect my dots, well, that's a terrible last line. Let's try that one again. So each of my old lines was parallel to one of my new lines. The shape got bigger. If the origin was inside the shape, then it's going to stay inside the shape. If the origin was completely separate, like my shape was over here, then I'm going to end up maybe not with them overlapping like these did here. It's okay. They can overlap. They don't have to overlap. So here's example 2b. We have our quadrilateral JKLM, and we want to do a dilation with a scale factor of 1/2. So the previous problem was an enlargement. We made it bigger because k was 2. But now that k is less than 1, it's 1/2, this will be a reduction. We're going to make it smaller. So I'm going to multiply each of my numbers by 1/2, which is the same as dividing them by 2, right? Multiplying by 1/2 is the same as dividing by 2. So let's divide everything here by 2. That's going to become -5 and 1. That's going to become -1 and 4. This will become 3, 1, and -1, -2. So at -5, -5, 1 is our J prime, -1, 4 is our K prime, 3, 1 is our L prime, and -1, -2 is our M prime. All right, so there is my reduction. So there are 2 check-ins for you to try. This is the first one. You could pause now. I'm going to go to the next one if you'd like to see that. This is the second check-in. Answers are posted on Google Classroom. So for example 3, we want to identify the scale factor given the graph of the image and its preimage for the dilation centered at the origin. So what I'm going to do here is I'm going to pick a point. Let's say I pick point F and F prime. So F was at -1, 2, 3, 4, 5, 6, -1, 2, 3. And F prime is at -1, 2, -1. So if I took a value from the new and put it over one from the old, that'd be -2 over -6, which turns into 1/3. So that would be my scale factor. That is K. And it makes sense because my shape did get smaller, so my K should be between 0 and 1. So here's a check-in for you to try. Pause now if you'd like. The answer's posted on Google Classroom. So for example 4, triangle R prime, S prime, T prime is the image of triangle RST after a dilation of 3. So that was an enlargement. Which statements are true? Select all that apply. So the first one saying the coordinate rule would be 3 times x and 3 times y. That is true. The rule for dilations is you multiply the x and y by the scale factor, which is what we did here. B is contradicting that. B is saying we would have added 3 to them. So that is incorrect, right? You don't add on a dilation, you multiply on a dilation. The next thing this says is that the original segment RS would be the same length. It's equal to the new segment R prime S prime. That doesn't make sense because if the shape is getting bigger, the side lengths are going to change. So that is not true. For D, it says that the old segment RS will be parallel to the new segment R prime S prime. That is true. We learned that all of the original segments will be parallel to their new segments. In E, we're saying that the old angle S will be equal to the new angle S prime. That is true. From the very first thing we wrote, it said all corresponding angles are congruent. The angles do not change their measures. So then in F, where it says that the new angle S will be 3 times as large as the old angle S, that is not true because the angles are going to stay exactly the same measures. So here's a check-in for you to try. Similar idea. Which one statement is not true? So 3 of them are true, 1 is not true. You can pause now. Answers are posted on Google Classroom. So before we move on to the next problems, let's just do a problem where if we are given the point A is -2, 3, and we want to find the scale factor, find the point after a scale factor dilation using 2, we'd multiply these by 2. So that would be -4, and that would be 6. So in our next example, we are given the prime value, and we want to work backwards to find out what the original point would have been. So all we have to do is do the reciprocal of the k. So if k was really 2 over 1, we're going to multiply by 1 over 2. So if I multiply -10 by 1 over 2, that's -5. And if I multiply -8 by 1 over 2, that was -4. So in part B, if 2/3 was my original k, I'm going to do the reciprocal of that, which is 3/2. So -2 times 3/2 is -3, and 5 times 3/2 is 15 over 2. So you guys do check in 5, pause, answers are posted on Google Classroom. So example 6, you're making your own photo stickers. Your photo is 4 inches by 4 inches. The image on the stickers is 1.1 inches by 1.1 inches. What is the scale factor of this dilation? So we know that K is going to be the new measurement over the old measurement. The image, the new measurement, is 1.1 inches. The old measurement was 4 inches. So we're going to simplify this the best we can. If you turn it into a decimal, that's fine. It's trickier with decimals, especially if they don't round nicely. 1.1 divided by 4 rounds nicely enough. So we could say that K is 0.275. Or if you just reduced your fraction, it's going to actually get bigger. You could have said 11 over 40. But I'm perfectly fine with us saying that K is 0.275. So there's a check in here. Pause. Check your answer on Google Classroom. Example 7. You're using a magnifying glass that shows the image of an object that is 6 times the object's actual size. So K equals 6. Determine the length of the image of the spider seen through the magnifying glass. So they're telling me that the pre-image is 1.5. The old is 1.5. And if K equals new over old, then 6 equals new over 1.5. So I can multiply both sides by 1.5 so that I get 9. So here's a check-in for you to try. We're using the same magnifying, so we know that K equals 6, but this time they're telling us this is the image, and they want to find the actual length or the original old length of the spider. You can pause, answer is posted on Google Classroom. So for example 8a, we see that we have a dilation performed with a center of C. So we have this triangle here, which was my pre-image because it's labeled with a P, and we have this triangle here, which is my image because it's labeled with P prime. So this side here, 5, matches with this side here, X. This side here, 4, matches with this side here, unknown. This side here, 6, matches with this side here, Y. And they gave us some extra information that the distance from the center to the old was 4, and distance from the center to the new was 12. So my scale factor, if I do new over old, is 12 over 4, which is 3. So if it's a scale factor of 3, there's a few ways I can approach this problem. I know that each of my old sides times 3 will produce a new side. So 5 times 3 would give me x. And I know that the old side of 6 times 3 would give me y. So that would allow me to solve for x and y. The other thing I can do is set up a proportion. When we're dealing with similar triangles, we will use proportions quite a lot. So we could take something like 5 over x, because those sides go together, equals the 4 over the 12, because those numbers matched up as well, right? 5 went to the old shape, x went to the new, 4 went to the old shape, 12 went to the new. And if we cross multiply this, I would have 4x equals 60. Divide by 4, I got x equals 15, which is the same answer I had here. Sometimes it will make much more sense for us to set up a proportion, because it won't always come out to be so nice to work this way. So in example 8b, I would set up my proportion actually for this one. I know that in one shape, 12 corresponds to 5, and then the 6 corresponds to x. So I'm going to set up my proportion here. I'm going to do 12 times x equals 5 times 6, which is 30. And when I want to divide 30 by 12, I get 2.5. So this is an example where it's a little easier to set up a proportion than it is to just figure out the scale factor and multiply your sides by that value. So there are more for us to do. Actually, I think there's one more. Okay. So example 8c. For my sides, I have these two, so I can make a fraction where 4 plus 2n is over the 3n plus 24. And then picking other matching pieces. If I picked from this one first, I'll pick this one first. 2 over the whole thing was 6. This would be my cross multiplying to solve. It might help to put parentheses around these so you remember to distribute, because this is going to be 6 times 4 plus 2n and 2 times 3n plus 24. So that's 24 plus 12n equals 6n plus 48. Take away 6n. Take away 24 and divide by 6. And I got n equals 4. But the second part of this problem have degrees on them. Angle A is x plus 11 degrees, and angle A prime is 65 degrees. Because the angles do not change, I can set x plus 11 just equal to 65. So take away the 11, and I get x equals 54. So proportions only work for the sides, the things that do not have degrees on them. But if we're dealing with angles, we just set them equal. So the final two problems are tries. This is the first one. Pause now if you'd like. And then the second one looks like this. So all answers are posted on Google Classroom, and that is the end of section 4.5.